Welcome to my final year project presentation entitled Image Steganography, Secret Data Concealment and Detection in Digital Images using Least Significant Bit Method. What is steganography? Steganography is the art of hiding information and an effort to conceal the existence of the embedded information. Image steganography is the type of steganography using the digital image as the medium to hide and conceal important information. In my final year project, least significant bit is the method I use in image steganography. For your information, an image is made up of thousands of pixels, and each pixel consists of 3 color channels, recording the intensity of 0 until 255 in red, blue, and green color. Each value in the color channel can be converted into 8 bits of binary data. When the secret message is converted into binary format and used to substitute the least significant bit data in each color channel, the changes of the color will be very small until it is invisible to human eyes. Image steganography was no longer an unfamiliar method to hide secret information. However, most of the image steganography has faced the challenges of limited choices in types of embedded information. Besides that, most of the image steganography methods are having the imperceptibility problems. The objective of my final year project is to propose an image steganography method in embedding any type of message inside a 24-bit color image using least significant bit. Besides, this final year project is determined to develop an imperceptible least significant bit image steganography to secure the secret message being detected. Furthermore, this final year project aims to prevent unauthorized extraction of the secret message embedded in the image by Advanced Encryption Standard (AES) symmetric encryption. The scope of my study in my final year project are the least significant bit as the image steganography method, the cover image that resistant to data degradation during transmission, the secret key encryption to prevent data breaches, the types of information hidden, and the imperceptibility of the stego image produced. My final year project started by preparing the 512 times 512 bits of Layla image in PNG format that are famously used in image processing. Next, the secret message to be hidden applies to all types of format. Multiple files are acceptable as the files will be compressed in a zip file to be inserted into the cover image. However, the size of the secret message embedded depends on the size of the cover image. The data encryption started by entering the secret key into the program. To build robust and secure method of image steganography, the SHA-256 hashing algorithm and AES 128 encryption are combined for security purposes. The secret key entered will be converted by the SHA-256 hashing algorithm into a 256 bits digital signature. Then the digital signature will be transferred to the AES 128 for data encryption. The first 128 bits of digital signature is the AES initialization vector, while the second 128 bits of the digital signature is the secret key used in AES encryption. Besides that, The digital signature will be combined with the number of available embedding capacity in the cover image to produce a random number. The random number will indicate the position of the pixels in the cover image to be encrypted with the secret message in the ciphertext format produced by AES encryption. Starting in the second row of each 0 bits position in the binary format of the random number, the cycle repeats until all 0 bits are finished and then continues with the 1 bits. The first row of the cover image is used to encrypt the length of ciphertext and the header of the zip file. In the encryption process, input the personal secret key and secret message to be embedded in the cover image. A stego image is produced. The same goes for data decryption. By entering the same secret key used during data encryption, the same random number will be produced as the indicator for the program to decrypt all the hidden information inside the stego image. The same secret key will also generated for the AES decryption. In the decryption process, input the stego image with the correct secret key. The secret message will be extracted. Comparison is made between the cover image and the stego image produced. Both cover image and stego image are almost the same, and human eyes can hardly differentiate both images. The imperceptibility of the proposed LSB steganography method is tested by the PSNR value and the SSIM value. The higher both the PSNR and XXIM value, the higher the imperceptibility of the method to hide and conceal a secret message in the image. A set of data are tested by embedding 20%, 40%, 60%, 80%, and 100% of payload capacity into the LENA cover image. The PSNR value that are higher than 40 decibel and the XSIN index that are higher than 97% are considered as a good method of steganography in a color image. The results tabulated has shown even 100% of payload capacity had achieved the value of 51.19 decibel in PSNR value and 99.81% in XXIN index. The graph concludes that the lower the payload capacity, the greater the imperceptibility of the stego image. In conclusion, the proposed LSB steganography method had high resistance to data degradation and applicable to all types of secret message. The embedding capacity is limited to the size of the cover image, but the proposed LSB steganography method is secure and imperceptible. That is all for my presentation today. Thank you for listening and goodbye.